Hi. Philip, thank you for the introduction. I was hoping it was short, but you elaborated more than I was expecting. I appreciate it. I am very happy to be here at the C100 conference in Silicon Valley, and I have the distinct pleasure of having a conversation, fireside chat with Dr. Fei-Fei. Fei-Fei is a rock star. She is one of the most well-known researchers and scientists in the field of computer science, and I want to just do a quick introduction, but really have a conversation with Fei-Fei about 4 or 5 topics. We will reserve maybe 15 minutes towards the end for audience questions. We'll have them submitted through cards, and we'll have Holly bring them up. The topics are generally as follows. We're going to have a little bit of conversation about Fei-Fei's immigrant experience. She came over from China when she was a teenager, and we'll hear some about that. And then as she went through school, she obviously became a very important scholar and researcher in the science of computer science. And she came to Stanford in 2009. And subsequently, I think, had a number of very important projects that culminated in sort of the advent of what we all commonly know as artificial intelligence, or AI, really defining a lot of the key projects around machine learning and deep learning and neural networks. And then we're going to spend a little bit talk about what is AI. I think there are a lot of conversations in media and published reports about what it is and what it isn't. And of course, being at a C100 conference, we will also attempt to talk about how China and the U.S. are approaching AI, some similarities and some differences. We probably won't solve the problem, although if anybody can solve it, Fei-Fei can. And we'll sort of try to end on a note that is more about the future, how Fei-Fei sees how we go from here. This is a very interesting time for those of us in the technology field, and certainly for somebody who's at the forefront like Fei-Fei. So with that, please welcome Fei-Fei. So why don't we start at the very beginning? And you are much younger, so I won't tell the crowd how old you are, but I'm sure they can look it up. But you came to the United States in your teens, and you went through school here in the United States. Tell us about your early years in the U.S. and perhaps, I mean, obviously, you know, being an immigrant, what were your experiences, both positive and negative, if there were any?
Okay, I'll try to be brief. I was born in Beijing and grew up in Chengdu, so a very nice city with spicy food and panda bears. And I came to the U.S. when I was 16 with my parents. Landed in a very small town in New Jersey. Has anybody heard of Parsippany, New Jersey? Yeah. Oh my God. So, well, I guess those of you, especially with Bell Labs, and yeah. So I went to part of high school in Parsippany High School in New Jersey. It was a very different experience. Everything I knew about Chinese school, the U.S. is opposite. And learned English there. Was mostly in ESL class, so English as second language class, and spent some time working in Chinese restaurants and doing various jobs as first generation immigration kid. And I was very lucky I got into Princeton, and to this day I think Princeton admission made a mistake. I had very low SAT scores, but I was very lucky that they gave me a scholarship, probably need-based scholarship, and my Princeton years was mostly tale of two cities. So half of my week from Friday to Sunday was Parsippany, New Jersey. I had to open a dry cleaner shop and became the CEO of a dry cleaner shop and was running the shop to also just to make money because my parents work in that shop. So spend most of my weekends there. And then Monday to Thursday, or most of Friday daytime, I was in Princeton studying physics. I was very much, the only reason I went to Princeton or have heard of Princeton was Einstein. I was passionate about physics and had a tremendously good time there, except I didn't have any social life. So apparently Princeton is famous for eating clubs, so I wasn't part of that. Maybe it was a good thing. But something really intellectually interesting happened when I was a physics student. If you're ever trained as a physics student, I think you're compelled to ask the fundamental questions of the universe. Where does the universe come from? What are matters made of? Where is the universe going? And I also noticed that the giants of 20th century physics in their late stage of their life, whether it's Schrödinger, Einstein, Planck, and many of them started to asking the question of life. What is life? So I became very interested in the question of what is life, especially what is intelligence in life. And because of that, I decided that I would shift from pure quest, the scientific quest of my interest shifted from studying the physical matters of the universe to the intelligence of life. And that's when I decided to do grad school at Caltech.
Right. I was going to ask you because I became an engineer because I couldn't cut it at physics. So you decided that physics was too easy. You wanted to go and understand meaning of life. So you went to Caltech.
Yes.
How did you choose Caltech? That's all the way on this side of the country and obviously away from Parsippany.
So, of course, I'd like to say the reason I chose Caltech was later I met my husband. But the real reason was MIT was too cold. I visited MIT. If you get accepted, you get to visit. It was really stormy and everything. I was like, I've had, many years of New Jersey. I'm gonna try something warmer.
Good decision.
But I did meet my husband there, so.
Yeah. Well, and after Caltech, you did go back to the cold for a little bit in University of Illinois. Is that right?
Yeah. So I think I've always wanted to be a scientist. I've always wanted to be a professor. So I pursued an academic career after PhD. My first job I got. It was the only job I got was University of Illinois, so I was there for less than a year. It was a quick stop there. Quickly, Princeton got back to me and said, "Come back to your alma mater." And at that time, my parents were still living in New Jersey, so I went back to Princeton as a professor in the computer science department.
Yes. So you were there until 2009?
Yes.
Yeah. And so while you were doing your research and a professor, you're probably the best known for, in the tech circles, this whole effort around ImageNet. How many of you have heard of ImageNet? Okay. Oh, not bad. I wonder if it really have heard of it, just raise your hand.
Jerry's going to quiz you.
No, Fei-Fei is going to quiz you, but this is obviously something that is very technical for a very long time, until it became the most important, one of the most important measures for deep learning and machine learning. And I think it's worthwhile just maybe describing the project, Fei-Fei, for this audience, and then describe when it became sort of the coming of the AI age, if you will, in 2012.
Okay, so I'll try to be brief, but I do want to say that AI is a very new field. It's only 60-year-old. So about 60 years ago, a group of pioneering computer scientists had that audacious dream of can machines think? Can machines be intelligent? That is the very essence of the birth of AI. And to this day, as an AI scientist, I think that continues to be our dream. So once that question was laid out, Alan Turing was one of them who started that question. Computer scientists started exploring different ways to answer this question of can machines think? Well, this is a very philosophical question. How do you even define what thinking is and what intelligence is? As humans do best, we look into ourselves. So as we think about making machines that think, we want to first replicate the capabilities we have as humans. So what are our intelligent capabilities? We speak, we hear, we see, we feel, we navigate, we do things. So these are some of the essence of the field of artificial intelligence, and each one of them, I just said, became a subfield. For example, the capability of hearing and speaking become speech recognition and natural language understanding. The capability of doing things and navigating, manipulating become robotics. And the capability of seeing and understanding became computer vision. So I personally started working in computer vision as a subfield of AI. And without getting into details, if you look at how the way nature designed human intelligence, vision is one of the most important components of that intelligence. So cracking the problem of vision is very related to cracking the problem of artificial intelligence. So we've been, as a field, working for decades on cracking the problem of computer vision. And one of the holy grail problem in computer vision, or in human vision, is to understand objects. You open your eye, you can see what are the objects are surrounding you, the chairs, the people, your mother, your baby, the flower, the door, the car, the key, and all that. So there has been a multi-decade effort in working on object recognition, and we've been making progress from, very early rule-based system where we piece together rules that humans come up with, to in the 1990s, there was a really breakthrough moment in AI, in the field of AI, is that a sister field started to blossom in computer science, and that field was called machine learning. Machine learning is to combine statistical probability theory and all that with the capability of computer science, and it became an applied math field that can use data and analyze data, learn from data to make predictions. So the area of computer vision and machine learning start to combine in the 90s, and a lot of new exciting things are started to happen in academia. That's where the general public still don't know about AI much. That was around the time I entered PhD. Grad school is very end of that 1990s, first year of 2000. And we started working on this holy grail question of object recognition, and we felt we were close to cracking it as a field. But there was many years of stagnation, because somehow our machine learning algorithm can work with small amount of data, but it's just not quite there. And that went on, fast forward to 2007, I was a young assistant professor at Princeton. And through a series of discussions with my students, we began to realize there's a new way of approaching this, is that we need to reboot machine learning and computer vision, not through keep tweaking an algorithm, but through a whole different way of thinking that is the data-driven way of thinking. Why did we think that? Because children do that. children learn from lots of data and experiences and experimentation in the early years of life, and we believe that would be useful for AI. So long story short, we started a 3-year endeavor of making this ginormous data set called ImageNet. At that time, the scale was unheard of in the field of computer science. We collected billions and billions of images from the internet, including Yahoo search, and also found a clever way of crowd engineering and annotated 15 million images, organized that in 22,000 classes of objects, and just created this enormous data set called ImageNet. And then we open sourced this entire data set to the world of research and started an international competition and challenge.
The challenge, right.
And 2012, with the availability of ImageNet, with the advances of GPUs, the field of computer science started to converge on a family of algorithms called neural network algorithm, and pretty much cracked the problem of object recognition. That was a very big win of AI and the computer vision field, and that was what Jerry was talking about, is 2012.
So, but just to give people the challenge, to give you guys some context, the challenge in 2011, you know, a good company or a good contestant that tried to solve the challenge would get about 25% wrong. That's the error rate. And in 2012, the error rate kind of broke through to below 16% or so. And then last year, I guess the majority of the company got less than 5% wrong.
And human error is around 5%.
Yeah, so we're nearing that human error rate. And my understanding is that there's private efforts even at Google, for example, it's even better than 5%. And so, so through these neural network learning algorithms, and the learning has become, the recognition has become so good that it is as good, if not better, than humans. And this is really the confluence, as you said, because of processing power, the ability to implement algorithms on hardware, and the confluence of data. And essentially, Fei-Fei, would you say this is now the model for many, many other applications, not just vision, but also obviously some of the other areas you touched on?
Yes, I think if you look at the industry now, this combination of labeled data, big data, and neural network algorithm, and of course good processing hardware is what people are seeing as the deep learning revolution. And it has tremendous power in speech recognition, natural language understanding, you know, medical diagnosis, chatbot, vision, self-driving cars. The application area is really wide.
Yeah, I would say that if you look at the field of AI now, and it has gotten a lot of attention, the real typical applications today, that if you look right through it, obviously a lot of people think autonomous driving is probably one of the key applications that broadly uses a lot of the AI techniques, because it uses vision, it uses mapping. And do you think, I'm afraid to ask you for predictions because I think everybody wants to know if the cars are going to drive themselves. But what is your sense of progress? Are we at a rate in which in 5 to 10 years autonomous driving is going to be the norm, or do you think there's always going to be a human element in these kinds of tasks?
So I think there's a saying that humans are super bad at predicting, overestimating near future and underestimating long-term future. So I think AI technologies such as self-driving car, long-term wise, is an unstoppable trend. You know, machines will become, especially this kind of in the setting, transportation will become more autonomous. But in terms of predicting, is it 5 years, 10 years, there is still quite a bit of uncracked, unsolved technical challenges So this is where we tend to hear a little bit of AI hype these days, is that self-driving car as a technology, I personally think still have some real challenges we haven't resolved, from mapping itself to vision, predicted road condition, the human element, and all that.
So before we get to some of the other topics, you are taking a sabbatical from Stanford right now, and you are the chief scientist for the Google Cloud group. Maybe there's probably no other, probably only a handful of companies in the world that are doing as much in AI as Google is. What's your experience been? What kind of things are you doing at Google, and how are you seeing the research that's being doing there affecting?
Yeah, I remember we talked about that before I took the sabbatical, right? So the reason I decided to take a sabbatical at Google Cloud is really, I feel so passionate about AI as a technology and its potential power and benefit to all industries that I really want to democratize AI. Just like ImageNet democratized data and computer vision, I think that the current advances of AI is ripe for the first wave of democratization. And if you think about democratizing AI and delivering that technology to as many businesses and people as possible, then cloud is the singular biggest platform. Cloud is an invention humanity has made that reaches the widest range of people. On any given day, Google Cloud touches billions of users worldwide through our tens and thousands of business partners and customers. So that was the motivation of me going to Google Cloud and form a team to deliver that. And I've been there now for 15 months. Our team has grown more than 10 times, and our product line has grown also n times. And I just feel very excited to see that this technology is being democratized through this very powerful platform.
But it sounds like it's just the beginning.
Yes, it's just the beginning.
Fei-Fei was the author of an op-ed in the New York Times dated March 7th. I don't know how many of you saw that. And the title was How to Make AI That's Good for People. And you've been advocating this whole concept around human-centered AI, which I think is such an important philosophical and practical concept that it could be very revolutionary in the way not only thinking through how we do research and how we think about it, but also in this day and age where there are a lot of fears and challenges that people think about AI in terms of how it interacts with humanity and a lot of the social issues, whether it be jobs or our economy or otherwise. Maybe you could just take a few minutes and talk about how did you come up with this idea of human-centered AI, and what does it mean to you? For those of people who didn't read the op-ed, maybe you can describe what you said in there, and then we can talk maybe a little bit about how that's evolved.
So, as I said, AI is a very nascent field. It's only 60 years old. Clearly, it has gone from phase 1 to phase 2, right? Phase 1 was a niche academic field that most of you have not heard of or wake up thinking about, but people like me working on every day. But phase 2 now is that it has such an impact at the societal humanity level that we're all discussing this. So as a AI educator as well as a scientist, I think deeply about what this technology means to me. And I like to tell my students, every student in my lab, to keep in mind there's nothing artificial about artificial intelligence. It is made by the people with the goal of helping people, and it will impact people's lives. And that really is the deep conviction I have for AI. So in other words, machines don't have independent values. Machine values are human values. And with that in mind, what is the future of AI? And that was the thesis of my human-centered AI op-ed. And there are three elements, in my opinion, about human-centered AI and the future of AI. The first element is that AI as a technology has a lot of room for growth and advancement, and it needs to be inspired by human intelligence. Today's AI is extremely narrow. There's a semi-joke is that today's machines are fast, accurate, and stupid, whereas humans are slow, sloppy, but brilliant. So in many cases, yes, our AI can recognize many species of dogs, but it doesn't have the nuance of human emotion, understanding, intention. So there's a lot for AI itself to advance, to learn from human intelligence, to be more flexible, to be able to do unsupervised learning and all that. That's the first element. Second element of AI is the technology should be human-centered. Every time I talk about AI, the first question I get from the public is, what about jobs? And that's a real concern. AI has a potential to disrupt job market, and the word is replacement. And I want to change that word. I want to replace the word replace and change it to enhancement. AI technology has way more potential to be of augmentative, assistive value to human lives and human work. For example, our doctors. I worked a lot at Stanford with doctors. We work in AI and healthcare space for the past 5 years. And I look at the way that doctors deliver value from their brilliant reasoning capability, detective capability of diagnosis, to the communication with the patients, to the treatment. Much of that work is completely irreplaceable by machines. Yet, a lot of their busy work can be assisted. If you're a nurse, you're spending a lot of time charting. If you're a doctor, you have many sources of information that you would get a lot of help from aggregated data analysis. So that is AI's value. It's enhancement to humans, not replacement. That's the second pillar of human-centered AI. The third part of human-centered AI is a call for a lot more research and understanding of AI's societal and human impact, whether it's job impact, organizational impact, legal impact, AI and ethics, AI and culture, AI and healthcare, AI and education. I want to say every vertical, every aspect of our lives will be impacted by AI. Is our society ready for that? Do we have enough studies that are guiding our thinking, guiding our policy? So that is the third component of human-centered AI. And I came to the lunch talk by Ambassador and Secretary Gary Locke. I cannot agree more with what he said, that we need to invest in the innovation, in the study, and in the education in these areas in order to really find answers and work collectively together on this.
So your 3-point is really saying we have to continue to innovate at a very fundamental level, because even though today the machines can recognize images faster and more accurately, there are still so many more ways in which intelligence or knowledge or wisdom can be learned, and we have not figured out the fundamental aspects of it. But yet, as the applications grow, your second point is enhancing humans and not replacing humans. And the machines are not, the machines only are a reflection of what human beings are. And the last is a real dialogue and research and investment in thinking through how to guide these efforts. And I think these are really refreshing guidelines in a world where most of the dialogue, especially in this world, in this current environment, is about fear. And I think as scientists and scholars and even people in technology, and in fact you have mentioned something, Fei-Fei, that this is a time that reminds us of the last sort of major revolution in science, or maybe even the Human Genome Project. Maybe you could talk about the analogies that we have from the past, whether it's physics or Human Genome Projects, and then what does this imply for the future, and why is it important for us to be investing in these three goals?
Yeah, so Jerry, you and I had some conversation about that. As a Chinese American scientist in AI, there's no doubt I get to ask a lot of questions about competition between companies, between countries, and especially in the space of AI. And as a student of physics many years ago, I get reminded that the last great scientific industrial revolution was the beginning of 20th century, the amazing modern physics revolution that really changed the meaning of our technology and science. And I want to ask anyone in the audience, do you remember which company in the early 20th century owned modern physics? Which country owned modern physics? I think the reason I want to ask that question is that 100 years later, modern physics made our collective human life better as a whole species, humanity. It's not a company that won a race, or not even a country. There will be at times certain technology was led by certain company or country, but at the end of the day, we all benefit. I know that's a very idealistic way of looking at science, and that's why probably I'm a scientist and an educator. But I want to say that because even though there is going to be competition, there's probably going to be difficult and challenging times if we have the perspective from one company or one country. But I believe science fundamentally has no borders. The benefits of science fundamentally have no borders. And I really want to see AI, such a powerful technology, to be developed for humanity and to be used by humanity.
Well, I think that brings us to probably 85% of the questions we're getting up here, which is U.S. and China. You're Chinese American, and obviously you have built your career here in the U.S., but you have maintained ties with China. The government, Xi Jinping has all but declared that China's AI advances is strategic for the Chinese agenda. And then in the U.S., there has been cutting in research funding, especially around traditional science and technology. So it feels like there is very different views of how these two countries, and primarily the AI efforts in the United States are fostered by corporations and the private sector. So maybe just as a background or your sort of own understanding, what is going on in China in AI, and what is going on in the U.S. in AI?
So first of all, it's not just China and AI. If you look at the past 3 years, starting from 2016 to 2018, there is about a dozen countries that have rolled out some kind of national white paper or policy about AI. So China rolled it out in 2017. I actually personally just participated in a meeting with President Emmanuel Macron in Paris when France rolled out its AI policies or strategy. So it's clearly a topic very much on the mind of global leaders in many countries. So China is a very vibrant place for AI. First of all, if you look at today's international machine learning and AI conferences, for many conferences, half of the authors are Chinese names. Some of them are probably Chinese Americans, but many of them are students and researchers from China. Just now, Gary also said that many startups are mushrooming in China, including internationally known unicorns. So, and my colleagues in China are very heartened by this government level policy support. In the US, it's a more complex story. So back in 2016, Obama administration actually had multiple AI conferences in the nation discussing AI policy. Stanford, on behalf of Stanford, hosted one of those Obama conferences. And at least personally, we were talking closely with Obama's OSTP, Office of Science and Technology Policy office and colleagues. So that the new administration had less involvement in AI so far from my perspective. But what's interesting in US is that US always had more deeper collaboration between academia and industry than many other countries. So Stanford AI Lab is deeply supported by a lot of gifts and research from the industry, and that part has been very vibrant and heating up. So I don't see a downward trend, but more an upward trend. And one example is there are also a lot of effort that's internationally supporting this cross-border talk. At Google, one of the most inspiring conversations I had with Sundar when I joined Google last year is the thought of opening a Google Research Center in AI. And he and I were chatting about what is the goal of that research center, and we both very just naturally agreed it should be open, basic science research. And Sundar, I remember saying that it's just good for humanity, that it's not a business unit, it doesn't have a business goal, but we want to encourage and participate in that basic science dialogue.
I'm going to try to get through some of these questions. We have a lot of questions, which is great. I think Linda, we're going to go by age, so I'm hoping is this yours, Linda? You are in a very sensitive area? Okay, so Linda being 92 gets to ask the first question. I think Linda is asking you, you're in a very sensitive area of R&D. In the current environment, especially for ethnic Chinese, has it in any way affect your work?
So, Linda, I am mostly a basic science researcher, meaning that in the basic science area, our research is largely completely open source and transparent. My students and I publish in open scientific platforms, just like all researchers. So from that point of view, there's an international understanding that it's just open and transparent. So I haven't experienced that any sensitivity because of the openness of basic science research.
Based on the amount of conferencing and publications, your counterparts in Chinese universities and research centers, are you sensing that they're very open about their research as well to this point?
So in basic science research community, and these are my colleagues in universities and industry research labs, it is very, very open. There is almost like a parallel universe that we live in, which is open publication. I mean, students in the audience, every morning you get archive notification about yet another 100 AI papers uploaded in the open platform. So that's mostly the world we live in basic science research. and so do the Chinese researchers.
Next question is from Tony. I think Tony's son, speaking like another MIT engineer. Just because she didn't go to MIT doesn't mean you have to ask a hard question. So Tony says 5% error rate is unacceptable. Unacceptable for many real-world problems.
Hold on. That 5% error rate is by my Stanford PhD student. So that is a high standard for human error.
Okay, so what is the limit on no false positive or negatives? We need 4 to 5 times the order of magnitude improvement.
So we can discuss offline because even 5% error is it's a very nuanced number. It's on a particular data set in a particular setting. So in many practical applications, we need to talk about the specific condition of false alarm rate versus a negative, type 1, type 2 error. So what I just want to say is this general technology of deep learning is already in many application scenarios, and there is very, very good indication that this technology is practically useful and powerful in many areas. But again, there is a lot of room for improvement. That I totally agree.
This question is talk about the fact that you talk about democratizing the AI. So you want to democratize AI and presumably globalize that democracy as well. Are you worried about the localization of the cloud by the Chinese government?
So I don't know too much about the localization of cloud. I don't really know exactly what that means, so I don't know how to answer that question. Do you know?
I was hoping I'd just do the ask. I do think that we are entering and this is more than just AI. I think the internet is entering a more fragmented. I mean, like when we started Yahoo, 25 years ago. And in fact, when the web first came out in late 80s and early 90s, it was a very open and accessible medium. And now the internet is really, I would say, much more fragmented than it was back then. You have, obviously, a lot of sovereign countries now imposing data and privacy rules. You have companies that essentially are so big with their user base that have their own rules. And then you have, obviously, the mobile internet being very different than the traditional internet that came before it. So there is a lot more fragmentation, and because everybody is trying to control the parts of the internet, either commercially or through their sovereign boundaries, it's a very interesting time. And I think that if you even layer on top of the complexity of AI, it's even more complex. So I know I'm not answering your question, but it's yeah. Okay, here's a question for Fei-Fei. There's a worry in the U.S. Trump administration that China will overtake or is already close to U.S. in AI. What do you think?
So this is where I really deeply agree with Gary's lunch keynote, is that there's always going to be a worry, there's always going to be competition, there's always going to be policies that is beyond my own personal understanding, but fundamentally what's most important is to invest in the future. Invest in basic science research, invest in STEM education, invest in the educational and our public universities. If we don't continue to invest in the innovation and education of critical technologies like AI, it's not about the other people, it's about ourselves slowing down the pace.
Well, I think it's clear that as we continue to evolve, the technology will continue to evolve. And I think this idea of human-centered AI allows us the opportunity to guide the technology. And it sounds like, Fei-Fei, you're advocating a world where there may be national interests like China or France or the U.S., because everybody's going to have it. And we talk about China because A, we're at a C100 conference, but B, Chinese is really, I think, taken this as a national initiative with a lot of resources behind it. You're advocating a more open dialogue and a platform in which we can all have this conversation for the better of humanity. There obviously will be challenges, but from your perspective, what do you think is the most important thing that we all can do in the audience to make sure that this dialogue is open and can be constructive?
Thank you for asking that, Jerry. So I think C100, I'm not a member, but I've admired C100 for many years for the role it has been playing, which is to really support and work on the building trust, building friendship, building dialogue and understanding. And whether we're scientists, technologists, entrepreneurs, policymakers, I think that's continue to be very, very important. The world is just more connected thanks to internet pioneers like you and many of the technology, and we're going to live in this world together. So for what we all can do, I just want everybody to share and remember that really machine values are human values. No matter how autonomous our machines and cars and computers will be, it's our responsibility to make it for the benefit of everybody's lives.
So I have a few more minutes, and I'm going to transition a little bit. Let's see how this transition goes. This is a question from Han, which is the next gen C100 participant. If machine learning analyzes a very biased data set, how do you have AI that doesn't perpetuate bias under the guise of being unbiased big data?
So machine learning bias is a big issue. So AI, again, AI is a technology that learns patterns and then recognizes patterns. That's how simple it is. If you have a math background, you understand that every machine is doing what it's told to do. So even though it's mathematically a little more magical, but at the end, it does what it learns. So when for example, training data is biased, the result of the machine learning algorithm will be biased, and that is already an issue. We have seen that machine learning bias will bias face recognition. Certain racial groups' faces will be less recognized. We have seen that in legal system, some predictions of parole decisions were biased because of the data. In medical system, if the input data is for a particular disease comes from only a biased group of patients, it'll have consequences. So this is a serious issue. The good news is the international machine learning AI community is very aware of this. If you go to our conferences, whether it's MIPS or ICML or computer vision, now every major conference now have lots of papers showing work to combat machine learning bias. We have lots of workshops on that. Google has a whole research team that is dedicated to combat the problem of machine learning bias. It's a technology problem. I do want to say that technology, this is not a problem unique to AI. The power of AI will amplify it, and we need to deal with that. But throughout the human civilization, whenever we create tools and technology, we're subject to that. And my favorite example is a low-tech example, scissors. For how many centuries, scissors are biased for right-handed people, right? That is a technology bias. And then it dawned on someone that we need to democratize scissors to the left-hand people. So we now have scissors for both kinds of people. So humanity has done this. We've made mistakes, but we've corrected our mistake. And AI is nascent. We need to work on this.
many questions that are pretty smart. Yeah, that I probably won't have time to get to, but Fei-Fei, you're a leading scientist, a renowned researcher. You're a mother of 2 young kids, and yet you have time to start a very inclusive, important initiative to include diversity in the field of STEM in general, but AI in particular. I would love for you to just describe what is AI for all, and why do you have gotten support from people like Gates and Jensen and others just to do what I think is so important in this day and age.
Yeah, so AI for All is a nonprofit organization I co-founded in 2017, and the mission of AI for All is human-centered AI education for diversity and inclusion, particularly towards high school students who are women as well as underrepresented minority. And 2018 AI for All has 6 campuses around North America. It's a summer program of 2 to 3 weeks long, and every campus has its own different uniqueness. Stanford is focusing on women. Berkeley is focusing on robotics for low-income students. Princeton campus is focusing on AI and policy for racial minority students. And we have CMU, Boston University, and Canada's Simon Fraser University. So AI for All started. The precursor of AI for All was a Stanford summer camp I started 4 or 5 years ago to like Jerry said, to include more girls into the future of AI. And it was motivated by a realization that in my professional life, around 5 years ago, I literally woke up one day and realized, gee, my world has 2 crises. The first crisis is the Terminator crisis. Everybody's talking about AI turning into Terminators and dominating humanity and all that. The second crisis is we have no women. For many, many years, I was the only woman professor in Stanford AI lab, and if you go to our conferences, it's around 10%, and it still is that way. And then these are 2 disjoint crises. Nobody made a connection. But with my former student, Olga Rusakovsky, who's now a Princeton professor, at that time she was my PhD student, we connected the dot. We feel that there's a deep connection between the diversity crisis and the lack of human-centeredness in AI, is that our technology, the way we educate our next generation students, we don't inspire them. In Silicon Valley, technology is a playground for geeks. It's this coding technology, and it's cool to do technology. But what about the human mission? When I talk to women and students with all walks of life, they're very inspired by the human mission of technology. And we realize that if we use that kind of way to educate and include them, we're more likely going to inspire students of all walks of life to participate in this technology. And once we have these students from all walks of life to participate in this technology, we will reduce the probability of Terminator coming next door. Because we'll have future technologists who are working on this for the benevolence outcome of this technology. So that's when we started the precursor of AI for All. We did that for 3 summers at Stanford. It became intensely popular. I can't tell you how many friends of mine have asked me to take their daughters. So last year, Melinda Gates and I had a fairly deep conversation about this. And in fact, our conversation became an article saying, Fei-Fei Melinda wants to combat the man with hoodies or something. That wasn't the point, but she was very supportive of this initiative, and Jensen Huang and his wife Lori Huang also became very supportive. So with Jensen and Melinda's support, they seed-funded AI for All. We incorporated it as a non-profit, and our organization has grown quite a bit, and now multiple companies have participated in this, and our goal really is to open more and more campuses worldwide. We'll start with North America, and to encourage women and underrepresented minority students to participate in the future of AI and human-centered AI technology.
Well said. Well, with that, I just want to thank you, Fei-Fei, for not only your leadership at Stanford and your current role at Google, but also what you're doing for women and underrepresented minorities in this country around AI, because as we have all seen, you said it much more eloquently. I think, especially when it comes to algorithms, it's garbage in, garbage out, and if we don't have inclusiveness and diversity at the outset, not only from a data set perspective, but also from the people who work on it, it is going to be a detriment not to have the kind of complete diversity that we could have. So thank you for your work in that. And I hope all of you enjoyed the panel, and please give a round of applause to Fei-Fei.
We'll have to. You're going to be here?
Yeah.
Okay.
I just came back.
Ladies and gentlemen.